Applications of differentiation. Objective: find relative extrema of a continuous function using the first derivative test. Discuss graphs of continuous functions. Definitions: a function f is increasing over an interval if for every a and b in the interval a is less than b, then f of a is going to be less than f of b. If the input a is less than the input b, then the output for a is less than the output for b. The function f is increasing over the interval if for every a and b in the interval a is less than b, then f of a is going to be greater than f of b. If the a input is less than input b, then the output for a is going to be greater than the output for b. Theorem 1, let f be differentiable over an interval I. F prime of x is greater than 0 for all x in the interval. Then it's increasing. If f prime is less than 0 for all interval, then it's decreasing. So positive slope means it's increasing, and negative slope means it's decreasing. Critical value is simply a place in the function if it exists where the slope is equal to 0. Or it could also be a place where at the particular point where it doesn't, the derivative does not exist. Let I be the domain of f. F of c is a relative minimum if there exists within I an interval such that f of c is less than f of x for all x in the interval. It's a maximum such that f of c is greater than f of x for all x in the interval. Then it's a maximum. The highest point and the lowest point in the interval. The function f has a relative extreme value, f of c on an interval. And f of c is a critical value. Then f prime of c is equal to 0. So it's a minimum or a maximum, or it's simply a place where it doesn't exist. It's undefined. So here we have the first derivative test. Find a minimum. F has a minimum if the derivative is less than 0 on a and c, and if f prime of x is greater than 0 on c of b, that is to say, it's decreasing on the slope is decreasing on the left and increasing on the right. So it's going down on one side and left and up on the other. F has a maximum at c if f prime of c is greater than 0 on one side, and then it's f prime of 0 is less than on the second part of the interval. So it's increasing on the left and decreasing on the right. So you have a maximum there. If it has a neither maximum nor minimum, then it has the same sign on both sides. No change. So here you can see it again. It's decreasing on the left and increasing on the right. You have a minimum. Increasing on the right and decreasing on the left, you have a maximum. And the slope is 0 at the maximums there, if it exists. In this case here, there's no sign change in either part of the interval. It's still negative slope. So in this case here, there's no sign change either side of the interval. It's still positive increasing. Now we look at this function here. There's just to graph it. Function by and find the relative extrema. Okay. Suppose we're trying to graph, we don't know any calculate. What can we do? We can plot a few points to determine which direction the graph seems to be turning. Let's pick some x values and see what happens. So they picked some x values and they graphed it. You can do it on your calculator. Okay. There's our graph. You can do it on the calculator. And there's the graph there. Okay. You see some features there from the graph. Now if I hit the trace button and then I enter values, let's say I want to find f of 2. So I clicked on the trace button and I put a 2 in, and it gives me the output at that point. I can hit another point and I said, let's say I put a 4 in. And I hit enter. And it gives me a value at that point. So using a trace function, I can evaluate it, doing it that way, and get more exact values. And okay. So found an expression for the derivative. So for this one, I found the derivative. Find where f prime of 0, the OR doesn't exist. Since it's a polynomial, it exists everywhere. Where is it 0? I set it equal to 0, and that's solve for x. So it's solving it for x. X is 2 and x is negative 1. Where are those points located? So I'll do the f there. F of negative 1 is 19. F of 2 is 8. So x to 2 and negative 1 are my critical points. Okay. So step 3, analyze the behavior of f of x between the critical points on a number line. Analyze the sign of f of x in each interval. So there are my critical points. So I pick test points to see what the behavior is between the intervals. So I let that my test points are negative 2, 0, and 4. So when I evaluate on the interval, f of negative 2 is greater than 0. F of 0 is less than 0, is decreasing. Then a f of 4 is increasing greater than 0. So what does that tell me here when it's increasing and decreasing? Increasing on one side of the interval, and then decreasing. I'm going to have a maximum there. When it's decreasing on one side and increasing on the other, I have a minimum at that location there. So I know where it's increasing and the points where it's decreasing. So I know those points there. So I found by the locations of those points where it's a minimum and where it's a maximum. So I know enough pretty much where the graph, where it's going to curve. Based on the test, it's going to curve, how it's going to curve on the intervals. Let's look at another one. And this one here, I'll graph the function and find the extrema. Just looking at it here, they tell us that where the maximum and the minimum are going to be. So the first thing I do is I find the derivative. So I find that here. Here. So I found that derivative there. Found where f prime of x is equal to 0 or doesn't exist. So set it equal to 0. It's a polynomial, it's defined everywhere. So set it equal to 0 and find my critical points. I have one at 3 and one at -3. So they're my critical points. That's coming from there. So now we want to find that behavior on the intervals of the critical points. So I'll have 3 and -3, and I pick test points here of -4, 0, and 4. And that tells me about where it's increasing and decreasing. So on this side of the interval here, it's greater than 0. So it's increasing here. And it's decreasing here. And then it's increasing here after coming out of that minimum. Okay. And it tells us there for our f values, you can find our minimum and our maximum to be at those points. And so they ask you to do. Let's look at another one. This one here, we're graphing it, find the extremum, and then sketch the graph. So the first thing I do is I find my derivative of the function. Okay, use a chain rule here. So I have here my f of x, my derivative of 1 is going to be 0. Derivative of x minus 2 is going to be 1. So using my chain rule, I get this quotient here. I want to find out where f prime is 0 or doesn't equal to, or it's not, or derivative doesn't exist. Okay. And if you look at the function, they'll never be equal to 0. Well, now we look at where it doesn't exist at 2. So that's the only critical value. So you want to analyze the behavior of f of x using the critical points. So we can partition the interval into 2 intervals and check the behavior on both sides using the test values of 0 and 3. The test points are 0 and 3. So I'll plug in on either side of 2. When I do that, I get decreasing on one side and increasing on the other. So if it's going down, then it's increasing. So I have a minimum. A minimum at 2, -1. And you can see right there it corresponds to the chart here, where it's decreasing and increasing. And there you see the graph of it. And my graph is here. Well, let's look at another one. Yeah. There's this graph here. So first thing I do is I find my derivative. I find where it's f prime is 0, it doesn't exist. So I factor it so equal to 0. So I'm given those 2 critical points. Then I find what the y coordinates are there for those points. Analyze the behavior on a number line between the intervals for 0 and 2. So those are my test points are -1, 1, and 3. So then I find out the behavior of those points there, and I see that it's less than 0 is decreasing, less than 0 is decreasing, and greater than 0 it's increasing. So now we know where it's increasing and decreasing. So if it was decreasing and then going up, you have a minimum at this point here, 2 and -16/3. So now we know where our minimum is, so we can, knowing where our minimum is, knowing where it's increasing and decreasing, we can sketch our graph. Let's look at another one here. Okay, let's take a look at this one here. Find extrema and sketch the graph. Okay, so the first thing we do here is we find, do another one. There. First thing is that we find f prime. So we find the first derivative here. We have a product, so I use my product rule to get it done. So that's my first derivative. Second step, find where f prime is 0. Go and define. Okay. So you have a 0 at 0 and 2. So if x is 0, this goes out, and f is 2, that'll go out. So my critical points are at 0 and 2. So I find out the coordinates of those locations, f of 0 and f of 2, give me the coordinates of the location. I want to analyze behavior on the critical points in the number line. It's for 0 and 2, so I plot test points between the intervals. My test points end up being -1, 1, and 3. So I plot the points and see if it's greater than or less than 0. So I see that it's decreasing on one side, increasing on the other, and then decreasing on the other side. So if it's going down, then it's going up. I have what here? I have a minimum. And if it's increasing, going up, then it's going down. I have a maximum. So that means that we have a minimum at 0, 0, and a maximum at 2, and for e to the -2. Those are the points where it's a minimum and a maximum. And there's the graph of it, and here's my graph here. Okay. And that's the end of that one there.